Welcome. In this video I'm going to show you how you can perform a post-hoc McNemar test for a Bhapkar test using Excel. The Bhapkar test itself I showed in the previous video and how that actually can be done, which was quite some work, but eventually we got there. And now the sorry about that, the post-hoc test. So we need the sums of, I'll be using this cross table as an example where people had to choose between what their favorite brand was, A, B or C. Then they were shown a commercial and then they had to ask again which brand they prefer. So first the sum, alt equals is the sums, and then we actually have the row totals, and we might also want the column totals, which is alt equals, and then we can actually copy that to the side, Ctrl C, Ctrl V, or use the autofill handle. Now that we have those, we can get started. The number of categories in this case is 3 because I have 1, 2, 3, and it should be the same both ways because this is for pairwise. Now the idea here for the post-hoc is that we choose, let me focus here a little bit, for example on brand A, so then we have x equals A, then we look at how many are not A versus brand A and not A afterwards. So that way we can actually, so this was before and this was after, so perhaps this would be slightly better, not X, and this is after and this was before. And then we can calculate a chi-square value, B minus C, so this one minus that one, over the sum of those two, and then we can get the p-value. So let's get started on that. The first thing we need is the a value itself, which is actually how many people, so this a, but afterwards it would be this b or this c. So we can use a function called index for that, equals index, and then the array is the cross table itself, and we're going to fix that by pressing F4 or just put the dollar signs in manually, and then the row number needs to match this value, and here press F4 again and again, so it's only in front of the B, and it needs to look that up in this here where the others are, and again we can actually fix all of them now, and it needs to be an exact fix. Then for the column number it's the same, so again we look up this value up here, but now in these up here, so then because this is about the columns, and there needs to be an exact match. And then we can close all the parentheses and we nicely get the 20. If I copy paste this down now, you see it gives me the 30 and the 40. You can imagine if you have a bigger table how that would work out. Now for B it's actually the 35 minus that 20. So what I could do is here I use a VLOOKUP and then simply look up this one, and again we're going to be fixing the column. It needs to look it up in this entire table for the dollar signs, and then column number 1, 2, 3, 4, 5, because the fifth one in this case has the totals, and it needs to be an exact match, and then subtract the 20. That gives me 15, and I can copy paste this down now. So as you can see, 40 plus 5 would be that 45. Then for C, it's actually the similar like the B, but in this case it's an H lookup, so I have to look up this one, so the 23, and then minus in this case again the 20, and that would give me the sum of these two. So how would that work? That would be the equals the H lookup, again this one, I'll put in the dollar sign in front of the column just in case. The table array would now be this table, block it with the dollar signs, and the row index number is 1, 2, 3, 4, 5, because we need the fifth row that has the totals. And again we subtract, in this case, the C16, which is the A, and that gives me the 3. So now I can copy paste this one down, and then D is everything else. So in essence that would simply be the 128 minus all of these. So this can be done by saying equals the grand total minus the sum of these, and then we can copy paste and that one down. As you notice, I put below the functions each time, so you can read with those as well. The chi-square value, like I've shown, that's the B minus the C, or the other way around, doesn't matter because we're squaring that, and then divided by the sum of those two. This one plus that one. Copy paste it down, and then finally we can calculate the p-value, the significance, which can be done by using various functions, but chi-dist is the oldest one of those. You take the chi-square value and you use a degrees of freedom of 1. Sorry about that. And then we copy paste that down again. Now because we are doing multiple tests, in total the number of tests is actually derived by using combine, and then this one, and we choosing 2 each time. So we're doing 3 tests in total. So what you could do is inflate these by using some kind of an adjustment. The most straightforward adjustment is probably by Bonferroni, which simply says to multiply the p-value by the number of tests that you're actually performing. So in this case the p-value needs to go times and then the combine of this one, which needs to be fixed, and choose 2. Now in some cases this might actually result in a value bigger than 1, which should be impossible. So what you can say is if all of this, and I copy it for now, is bigger than 1, then simply show 1, otherwise show the result. And now I can copy paste this down, and now we have here, and we can see that these two are still significant even after the correction. So a significant amount of people changed their mind about option A and option C. Okay, and that's all there is to it.